Day, everyone. My name is Therese Ticzon, and our lesson is all about measure of central tendency. So, measure of central tendency has three components: the mean, median, and the mode. Statistical measure to determine a single score that defines the center of the distribution. The mean or arithmetic mean computed by adding all scores in a distribution and dividing by the number of scores. Mean of the population is identified the Greek word mu, amounted that each individual gets. The total is distributed equal. Balance point of a distribution. So I have here a formula of the mean. Mean is equals to sum of all data divided by number of all data. Median. Median is a midpoint. No notation and standard formula, unlike mean. If the score in a distribution are listed in order from smallest to largest, the median in the midpoint of the list. It is point measurement scale below which 50% of the score is distribution are located. So median, always remember, is the center of the data set. Mode, customary fashion or popular style. In a frequency distribution, the score or category that has greatest frequency, it can be used to determine the typical or most frequent value or any scale of measurement, including the nominal scale. The mode is a score or category, not a frequency. So I have here an example of the mean, median, and the mode. So the problem is find the mean, the median, and the mode of the sample ages of students in a class. Which measure of central tendency best describes a typical entry of this data set? So the data set is here, ages in a class. So let's solve the mean. So mean is the sum of all data. So we should add this all data divided by the number of the data. So the number of data is 20. So mean is equals to 475 divided by 20 is equals to 23.8 years. And median, we should remember that the median is the center of this data set. So the center of this problem is 21 and 22. We should add 21 plus 22 divided by 2 is equals to 21.5 years. And the mode is the frequent number given in this data set. So the frequent or the frequent of this problem is 20. So the entry occurring with the greatest frequency is 20 years. So I have here a assignment for you all, for you guys. Same problem but different data set. So that's all for today's lesson. My name is Therese Maritigzon and I'll see you soon. Thank you.
A pleasant day to everyone. My name is Maria Cassandra Choresca, and we will be talking about a topic from Chapter 4, which is the assigning probabilities. The experimental outcome must be between 0 and 1 inclusively, and the sum of the probabilities for all the experimental outcomes must be equal to 1. For example, in tossing a coin, there could only be two possible outcomes: the head or the tail. The outcome of a head is an event with probability that is equal to a half, and the outcome of a tail is also an event in probability that would equal in half. So the probability of the head and the probability of the tail would equal to 1. Next is we have three methods in assigning probabilities. We have first the classical method, next is the relative next is the relative frequency method. This is appropriate when data are available to estimate the proportion of the time the experimental outcome will occur if the experiment is repeated a large number of times. So, in our example, we have the scenario which is a coin is flipped 100 times and heads appears 55 times. The empirical probability would the empirical probability of getting heads is 55. Number of times head occurred over 100, which is the total number of flips, or 0.55 or 55%. Next is the subjective method. This is appropriate when one cannot realistically assume that the experimental outcomes are equally likely and when little relevant data are available. For example, an investor might believe a particular stock has a 50% chance of increasing in value over the next year based on their analysis of market trends and company performance. So that is all. Thank you.
Good evening, ma'am. I'm Janet Villanis, and I'll be presenting counting rules. The first counting rule is the multi-step experiment where it involves series of steps and outcomes. Now, an example is how many outcomes are possible when you make a four-digit code using 0 and 1. Note 0 and 1 are your outcomes, and the four-digit represents how many times you're gonna do to get the outcome of 0 and 1. The next counting rules is the combination. Combination accounts the number of experiment outcomes when the experiment involves selecting R objects from a set of N objects. In this case, you have to select a certain number or given number by a question to the total number of objects. But order is not important in combination. The example is, customer enters a restaurant. He has to pick 3 out of 10 listed food items in the menu in order to have a common meal. Now, 10 is the total, 3 is the selected, but the difference between 2 is 7. So, in order to get this, is you have to multiply from 10 to 1, then the denominator, which is 3, you have to multiply from 3 to 1, then the difference, which is 7, from 7 to 1. The last one in the counting rules is the permutation. This allows one to compute the number of experimental outcomes when then experiment involves selecting R objects from a set of N objects where order is important. The difference is order is important in permutation. There's first, second, and third until to the last. Here is the question where you're playing with your group of friends. You're playing pool. There are 16 balls in total. But what is the permutation if you shoot 9 balls to win the game? Now, here's the formula. 16 is the total. The difference is 7. So, all you have to do is multiply 16 to 1, then your denominator, which is the difference between 16 and 9, 7 to 1, you multiply them. Then once you get your totals, you divide them, and you get your total outcomes, which is 4,151,347,200 outcomes, which is a lot of outcomes considering. To summarize, there are 3 types of counting rules: multi-step experiments, combinations, and permutations. Multiple step makes use of the diagram, which are a series of steps and outcomes. In combination, order is important, while permutation is order is important. Always take note. The next report will be done by Mr. Garino. Thank you very much for listening.
Thank you, Edward. So now let's proceed to statistics, the measures of dispersion. Dispersion refers to the extent of which data values vary. It tells us how spread out the data is. So this is the graph of measures of dispersion. It is measure the spread of the data. So next, what is measures of dispersion? It describes the spread of variability of a data set. They complement measures of central tendency, mean, median, mode, by providing insight into the extent data variation. So what is range? It's the difference between the highest and the lowest values in a dataset. It gives a quick sense of the spread. So the formula of the range is range equals to maximum value minus the minimum value. So here's the example, just 3, 7, 8, 12, 15. The range is highest is 15 and the lowest is 3. So it equals to 12. So that is your range data points. So the second one is interquartile range. So what is interquartile range? The range that measures the spread of the middle 50% of the data by subtracting the first quartile from the third quartile. It is resistant to outliers. The third one is a variance. It is the average of the squared difference from the mean, indicating the degree of spread in the data formula. So let's proceed to the standard deviation formula. So what is standard deviation? So the standard deviation is the square root of the variance. It indicates how much, on average, data points differ from the mean. And it is expressed in the same unit as the data. So next one is the mean absolute deviation, or the MAD. So the MAD is the average of the absolute differences between each data points and the mean. It gives a clear, intuitive measure of variability that is less sensitive to outliers than standard deviation. So to sum it up, measures of dispersion are essential tools in statistics that helps us understand the variability or spread in a dataset. They complement measures of central tendency like the mean median mode by showing how much data values is useful in different situations. Choosing the appropriate measures depend on the nature of the data and the presence of outliers. So that is all my report. Thank you so much. Once again, I am Dlonyer Mar. Thank you.